Genius Invokation TCG is a card game in Genshin Impact. It was a fun card game. You start each round by rolling 8 dice and use the dice to pay the cost for playing certain cards or actions. If you want to play cryo cards, you need cryo dice, and so on. Very simple, and also very random. But then there is this card, the Jade Chamber. It makes 2 of the dice always end up on a particular element. But how do they do this? The dice roll seems to be completely physics-based, so it's not a pre-recorded animation. In other words, how do you rig the dice? The answer might surprise you. Let's start by making the octahedron dice in Blender, also known as D8 for tabletop RPG enthusiasts. This is surprisingly easy. Just select all vertices and use the bevel tool in edit mode. Then we can make the inward faces of the dice using the inset faces tool. In the UV editing, we use the Smart UV project to quickly unwrap the entire model. Then mark every side of the dice to know their orientation. We want all of the arrows to point up. And now we overlap all of the UV into a single triangle in the UV map. This will make it easier to create textures for each of the dice faces in Photoshop, because it makes every face interchangeable. Then we separate the materials for each of the faces and the edges. We can then import the textures we made in Photoshop to the faces. And finally, we export this model with the path mode set as copy, so the texture will be included when the model is imported into Unity. Now, in Unity, we can create a simple plane for the dice to land on and 4 walls around the plane to keep the dice from falling to the abyss. We can then disable the mesh renderer component on the walls to make it invisible, and align the camera to look down on the plane below. Now let's put the dice model into Unity. The only thing we want to change here is the color of the edges. We want it to look like a rusty metallic gold, so raise the metallic map all the way to 1. Awesome! On freesound.org, we can find this nice dice roll sound, and chop up the best part in Audacity. Similarly, the ding sound can also be found here, but we have to adjust its bass and tremble to reduce its pitch and make it more pleasant to hear. With that out of the way, let's first create the behaviors for a single dice throw. In a script, we want to randomize the initial rotation, force, and torque applied at the start, so every dice throw is unique and different. Then, in the update function, we want to check if the dice has stopped moving by checking its rigid body's velocity and angular velocity to be 0. If it has stopped, then we will find which face of the dice is at the top. This is done easily through a collection of child objects attached to the dice. Using this loop, we can compare all of their Y position values and return the index of the face at the top. The index is determined in this order, and this order is consistent in this entire project. When we find the index, we can use it to swap the face texture to a lit version. We have to use these ridiculous switch case statements to keep the index order consistent, because Unity somehow randomizes the order of the materials in the mesh renderer, even though we have set the order earlier in Blender. Anyway, the final part is to play the lit up sound effect with a boolean check, so it can only be played once. We also add these 2 functions to play the sound effects when the dice collides with the floor, and other dice with the compare tag function. Then for a bit of a flair, I also added in a physics material to the mesh collider to make the dice more bouncy. And there we go! Now we have 1 complete dice. We can also instantiate 8 dice at once. We're 1 step closer to the final result. Okay, so let's go back to our original question. How do you rig the dice? The answer? time manipulation. Here's how it works. First, we take note of the initial condition of the dice. Then, we roll the dice normally. Record the winning phase of the dice, and rewind back to the initial condition. Because we already know the result, we can rotate the dice so the phase we want to win is on the original phase. Then, as expected, when we roll it, it will end up with the phase we want. This time manipulation can be achieved through the use of physics simulate function, which will do all the physics calculation to an object in a single update frame, so we don't need to show the player the first dice roll. Unlike a regular 6-sided dice, the amount of rotation needed for each phase is not the same. But we can create a simple scriptable object which keeps a table on how to rotate to each phase. Now, here's a cool trick to rotate the dice easily. Just separate the mesh render component as a child object. We don't need to do any complex calculation with rotations and quaternions. And now we can scale it up to 8 dice rolls and create a nice UI to control what we want with the dice. So far, so good. But of course, it's not that simple, is it? It never is. For 99% of the cases, this method works fine. But it's not 100% perfect. Because Unity's physics system is not deterministic. That means even with the same initial condition, the final result may vary. The physics has an inherent randomness based on the time between frames and on different devices. To solve this, we need to make the second dice roll exactly the same as the first one, without any physics interactions. The only way to do that is to record the exact movements of the first dice roll in every frame. That includes the exact time when the dice play sounds. Then, when it is time for the second dice roll, we rotate the dice to end up with the phase we wanted and play back the movements of the dice. The result is a perfect animation replayed twice with different results for the dice. Okay, so this part is recorded live without any scripts. So let's see if this is going to work. Okay, let's start with all dice 1. Yep, that works. Let's go with all cryo. Ooh, okay. What about for pyro and for geo? Nice. I mean, it's kinda satisfying, isn't it? But it's also kinda creepy because your brain told you that all of this like animation was like random, right? And it is, that is what we coded in, but somehow it always shows up what we want. Which is really awesome. So there we go. I hope you guys find this video interesting and informative. If you do, then don't forget to like this video and subscribe for future contents. If you want to support this channel, I recently opened a Patreon page where you can watch my videos earlier, among other benefits. Or you can buy me a coffee on my coffee page. And with that, I think I'll see you guys later. Goodbye.